I'm sure that everyone is sitting at home now because of the COVID-19 measures. And as soon as we get the green light from the government, everyone will be looking forward to go out and practice some sports. And now you can see what type of sport you are going to practice, and it will depend on the location in Canada, where do you live or where you are going to travel, or the type of sport you are going to practice. So how do you choose your shoes? So it depends on the activities, what you are going to do. If you are hiking, if you are going to have to go to a skiing resort, or if you have an skating or skiing, so or whatever the type of sport you wanna use, then you choose the right shoes for it. Now the question is, do you think building have shoes also, or what type of shoes or footing do the buildings have? That will be our topic for today. We are going to talk about the foundation. So our object now will be the list of different types of foundation, explain the differences between them, choose the suitable foundation type, and design a single foundation. So the design example will come in a different video later on. Now, what are the different types of foundation for a building? We can speak from 2 points uh, regarding the depth of the foundation. We can say that shallow foundation, or we have deep foundation. What are they? The shallow foundation, when you have some excavation in the soil for a few, like few meters, or hundreds of centimeters, then that, as long as you are excavate from the surface of the soil and place your reinforcing bars and pour the concrete, we are talking about shallow foundation. The deep foundation will be designated when you have your foundation penetrating through the soil. You are not really excavating, you are hammering or inserting your foundation through the soil. So how we can do that, and how we can decide on the types of foundation we are going to use, and what are the factors that affect that choice of the foundation. Now, it depends on many factors actually. How high you're building, you know that each floor has its own weight and the live load, and the more floors you have, the heavier will be the load on the foundation. So it depends on the type of the building, how many floors, and the load from the building. That's one factor. The other factor is the soil. How strong is your soil, and what are the type of the soil? You have clay, you have sand, you have silty soil. So what type of soil, and how we know the soil type? Here in my project, we have a in my office, we have a project here. I brought you some sample of the soil report. You have here the plan of the building, that's the plan, and here you can have different boreholes throughout the site. So you have a soil engineer or geotechnical engineer, they carry out boreholes and they take samples from the soil, and when they take these samples, they analyze it, and then they can give us a soil report. And the soil report is something on this side of the slide. Then you can have with the depth, it tells you what type of soil do you have, and it goes very deep as much as you can, and it depends on the soil, the type of the soil, and how far they can go to. And this soil report also will tell us the if we have groundwater or not. So the importance of this soil report, it tells us the type of the foundation, the type of the soil, also that can determine how you can carry out the excavation process, what type of equipment you can have. Also, it tells us, do you have groundwater or not? And the groundwater can affect the structural design, and also can affect the construction schedule and price. So if you have groundwater like that, you need to have a pump to dewatering process, and then you can pump out the water from the site and through this hose, and it goes out. So that should be mentioned on the drawings, and the contractor should count for that, for his price and for his schedule. Now the deep foundation, when we speak about that in details, you can have concrete piles or caisson, we call that in Canada or North America caissons. In this picture you can see different concrete piles, and they are very deep in the soil. I was working on this project that was in the Gulf region, and you can have it here for about 12-meter deep pile inside the soil, and you put the steel cage, you pour the concrete, and you can have the dowelling bars sticking out from the top of the pile, and then you can have at the top the foundation or the pile caps or the mat above these piles. So it is concrete piles or caisson. We can have also H piles. The H piles are the steel members which we designate in Canada as W section, or in other part of the world as an I beam. We call it H piles, and they will be hammered inside the soil, and the capacity of the pile will be determined based on the soil report and the size of the H pile. Helical piles, they are like screwed piles which will be rotated and it will penetrate the soil, and it depends on the size of the helical pile and the depth and the soil capacity. You have a bearing capacity for these piles. Micro piles, they are very small, tiny piles, and they are very adequate for existing building or in tiny spaces. They have small machines and they can go and you can install micro piles. So that's also designated as deep foundation because they go in deep inside the soil, and so it will penetrate the soil. So it's not like something like excavation and pour the concrete. That's a shallow foundation. But here we are talking about the deep foundation. Again, concrete piles or caisson, H piles, helical piles, or micro piles. The shallow foundation, as you can see here, you have the surface of the soil. The contractor excavates the foundation size and dimensions. He places the reinforcing bars, and we make sure that we have a concrete cover. In this case, we have a concrete cover of 75 millimeter, and then you can have different types of shallow foundation. We spoke about the deep foundation. Here we have for the shallow foundation different types. What are they? We have single footing, and we have combined footing, strip footing, and raft or mat foundation. So the single footing will and combined footing, it will be a small footing for one column. The single footing, it carry only one column. Combined footing when it carries more than one column. Strip footing is that's here, that's the sample of the strip footing is underneath the foundation wall. That's a strip footing. And raft or mat foundation, we have a sample here from this part. It's a mat or raft foundation. The single footing, as I just mentioned, it's footing for one column, and here you have a column, this shadowed area, and the dotted area here is the spread footing or single footing for it. And when you have a drawings, you want to make sure that they can locate the foundation on the site. So we have the grid line, this grid line, and this grid line, and we showed on our drawing how far the foundation will go from this grid line and from this grid line. And we give the foundation type F5B, and there is a foundation schedule. We give them what's the size of this foundation, this dimension, and this length, and the depth of the foundation. So they have the three-dimensional information of the foundation and the reinforcing bars. And here in plan we show them how to locate this area on the site. The other one here, it's a combined footing. Combined footing, you have a column and you have a shear wall, and because of the foundation here is interfering with the foundation of the wall, you can't have separate or single footing for every one of them. Based on the geometry, we found out that they have to be combined, and that will be a combined footing, and they have to be, it's had a special design for that. So that's a single footing and that's a combined footing. Now if you are going to speak about the design of the foundation, you have soil pressure underneath the footing. When you have your shoes on the on the sand and you are on the beach, you look at the sand underneath your foot, you have the trace of your foot of your shoes on it. So the same thing is for the foundation underneath the building. You need to have the pressure underneath the foundation. So you wanted to make sure that the pressure from the building or from the footing is less than the bearing capacity of the soil, the allowable bearing capacity of the soil. So here we have the BS as the unfactored load acting on the footing, unfactored. You remember when we designed the column, we multiplied the dead load by 1.25, live load times 1.5. Here, when we design the foundation, we have different ways of designing it. One of them is based on the service load, and the service load is not combining, not factoring the load. So in this case, you have the unfactored load. You calculate the all unfactored load, and here from the soil report, you know the allowable stress or bearing pressure of the soil. When you calculate the allowable bearing pressure, and you can estimate a specific area for the footing, and you make sure that the allowable pressure, which will be kilonewton per meter square. For example, if you have a good soil and it gives you a bearing pressure of 500 kilonewton per meter square, 500 per meter square, and you have the load of the column at the foundation level as 5,000 kilonewton. So the 5,000 kilonewton, you divide that by the allowable bearing pressure is 500, then you need 10 meter square for the foundation. So if you take a foundation 3 by 4, it gives you an area of 12 meter square. So 12 meter square times the 500, it gives you 6,000 kilonewton as a bearing load. It can carry a load up to 6,000. Now in the foundation, when we design that, we have to count for the own weight of the foundation itself to be added to the load of the column. Now how we distribute the load on the soil. So we have here, if my column is centric in the center of the foundation, I will have normal pressure, and we know the normal pressure is the load divided by the area of the foundation, and this pressure should be uh, compared with the allowable stress pressure of the allowable bearing pressure of the soil. So P divided by the area of the foundation should be less than the allowable bearing pressure of the soil. So we want to make sure that the column is in the center of the foundation. The other one here, if you have the column is eccentric from the center of the foundation, then you can have the soil pressure at one side is more than the other, and it can change based on this distance. So when you have a distance even bigger than this amount, then you can have compression here, and it will be have an uplifting here, which is not allowed, and that will be unstable foundation. So you want to make sure that your column is in the middle of your foundation to provide you with homogeneous or uniform distributed load pressure on the soil. And this is a big item looking at when you are looking at the foundation wall, because in the foundation wall it will be at the property line, and you want to make sure what are my edges for the foundation. So the architect should consider that they design when they put the footprint of the building, and the structure engineer, they should coordinate together with the landlord about are they allowed to extend the foundation to the outside of the property line or not. So now if we are going to speak about the foundation design, what are the steps? The first one is to calculate the foundation area. When we calculate the load on the foundation, and we know from the soil report the allowable bearing pressure, I can calculate the area. Then I have to estimate the thickness of the foundation. It's a trial and error. We can start from 500, 600 millimeter square depth, and then we check the thickness. This thickness, is that adequate to resist the bunching shear and one-way shear, and we'll speak about that in another time. And then we can calculate the reinforcing bars required in the foundation. So when we design the foundation, what does it mean? I need to know the area of the foundation, I need to know the thickness of the foundation, and I want to make sure that this thickness is good enough to resist the bunching shear and the one-way shear. And after we make sure that it's safe for that, now we can look at the reinforcing bars. How many bars do we need